Hi, good morning, all of you. I am struggling to make my. Why this is not the real space? I think there is a problem in my video. Do you all listen to me? Do you all listen to me? Okay, thanks a lot. Actually, there is a problem in my video settings. So this is persisting me from yesterday. So I'll carry on without having video. Is it okay for you, or anybody would? So there will be only voice in this video session. Okay, there won't be. Only voice in this session. There won't be video. Okay. So guys, yesterday, without much. Okay, sorry, it's fine. Without much description, let us swing into the action. Yesterday, I stopped exactly at a point where I was trying to explain you the t-test, right? So if you remember the yesterday session, I was explaining the t-test, and the session was closed abruptly. And by the way, I'm not closing the sessions. The sessions will be closed by themselves. Okay. Now in this video, in this session, let me. I'm just checking my. Oh my God! I don't know why this is not going on. I think now you should be able to listen to me properly. My audio output was not good. My volume is very low. So all of a sudden my computer, I'm just checking the settings in my computer. Please wait for me. Hello. Why it is going down? So the input volume is going down. Hello. Hello. It is just falling down. I don't know why. Automatically it is going down. Okay, anyway. So since you are able to listen, then okay, let me share my screen. Let us look into the. So yesterday, not the screen actually. I'll go back to the R. So do you all see my R session? I mean R screen. I think you should be able to see the R screen, right? Where is Zoom? Zoom has gone. Okay, where is R? So you all hopefully you are all of you are able to see the R Studio, right? Where is that? Okay, now you should be able to see the R Studio. Now yesterday I was trying to explain you how to do it. I mean I've shown you how to perform the t-test manually, which means you have to compute the mean and everything by yourself to perform the t-test. But in this section, I'm going to show you how to do that automatically. There is a function called t-test in R. So you just have to study what is this function. That is t dot test. Okay. So when you press, you will have this. Do you all see this documentation? So I don't know if you are seeing. I don't know which screen you are seeing. Actually, I opened the documentation screen. So here, you don't need to open the documentation screen. You can just, I mean, if you want to read in detail, then you have to open this in separate screen. You have an example. You say here t-test 1 to 10, y is equal to 7 to 20, something like that. You say here t-test, t dot test within parenthesis 1 to 10, y is equal to c 7. You know what is the c operator, right? This is colon operator. I mean, the first argument to this t-test is created by using, it is a number series 1 to 10, and it is created using colon operator. And in second argument, you got, the data is created by using the z operator. So you have two variables, x comma y, and the t-test is done. And here, if you see the syntax in t-test, you got quite a few arguments. There is x, y, and then there is alternative. This is a bit important for you because when we calculate the p-value, we need to know which the particular scenario for the t-test. You see, it is there in the textbook. You have to see that the p-value less than some value, p-value greater than some value, p-value is equal to some value. So there are three scenarios. Okay. Now there are two-sided, which means p-value is equal to some definite value. Uh, I mean p-value where x less than something like that. So I'll just take back to you the textbook. Wait, I'll show you the that is there in the textbook very clearly given. There are different scenarios while you perform the t-test. So I want to end this topic. I want to make it faster, but I'm not able to do that. It's just going on and on and on. The problem is I am see here the p see here like this. The p value t value less than minus 1.2. this is actually the lesser. This scenario is called lesser. And it is also possible for you to compute the p-value where the t-value is greater than some different value. This is calculated value, minus 1.2. Okay. And if the t-value is equal to, if I put is equal to here, that is two-sided. We call two-sided, and where the p-value should be divided by 2 when we take the inference. So this is what I'm just talking here in our documentation. So you should know which scenario you are using for the t-test. The alternative, alternative is alternative hypothesis. Now you have two-sided where you are trying to find the p-value is equal to something like that. Less is less than, greater is greater. That is, if you have assumed mean, you can mention, otherwise by default the value is 0. So that you have paid. If it is a paid t-test, then you have to mention paid is equal to true. Otherwise it is going to be the independent t-test. So yeah, there are two situations in t-test. When you are doing bivariate t-test, like we call it as paid t-test, independent t-test. There, the variance of the variables can be equal or may not be equal. Maybe equal, may not be equal. So we have to mention that explicitly whether the variances of the underlying variables are equal or not. Suppose if you are doing t-test on x comma y, there are two situations here. You will be performing the t-test by assuming that the variance of x is equal to variance of y, and variance of x is not equal to variance of y. So in all these circumstances, t expression is different. T-test try to compute the variance differently for different situation. So that is, so it is not simple. I mean, the problem is I want to explain you each and everything in detail. That is what is the problem. But you have to study all this. If you had studied statistics, I'm sure you should be knowing all these things. If you don't know, then you have not studied statistics well. By the way, I'm not teaching you the statistics. I have to teach you how to perform these statistical techniques using our programming language. Now, let me take cars data. So let's say head cars, and now you have the speed and distance. This is the bivariate, Now, this is a sample data. I'm going to test a hypothesis. The alternative hypothesis is x bar. For x bar of distance, I mean the mean of this variable speed is not equal to, is not equal to 0. That is going to be the alternative hypothesis. And the null hypothesis is going to be x bar of for speed or distance, whatever it is. Now, if you are testing speed, then your null hypothesis is going to be the mean value of speed is equal to 0. And the alternative hypothesis is going to be the mean value of speed is not equal to 0. That is the way we make the hypothesis. So you should know how to make the hypothesis. The null hypothesis is the x bar for either for speed or for distance, whatever it is. If you're, so let us test speed. Now the x bar for speed, okay, is going to be 0. This is the null hypothesis. Now how are you going to do that? How are you going to test it? T dot test cars, and then you can go for, what is the name of the speed? I don't know. I'm just assuming that I can do this. Yes, of course. Now I suspected that I will not be able to perform t-test by using the name, but our programming language is able to accept the name. So if the name is not accepted, then you have to use indexing. So this is the very first column. Now you have to press like this. So t-test is able to accept number as well as the name of the. Now let us look into the. So earlier we computed all these statistics manually. Do you remember there is a t value, there is a p value? These are the most important values from the t-test. Now you see, with a single stroke, we are able to compute the t values without much hard work. We are able to compute the t statistic as well as p value, and you just have to use this function t.test in order to perform the t-test over. Now you see, I did not mention anything for the alternative, the mu value. So by default, mu is assumed to be 0. You see here, mu is assumed to be. What is this mu? What is this mu? Can somebody write me in chart? Chart. This is assumed mean. We are comparing the mean of the speed with assumed mean. So here, the mean of what is the variable which we used for t-test? Speed. So we are assuming the mean of the speed. Sorry, we are computing the t statistic by deducting mu value 0 from the speed. So x bar minus mu divided by, so that is what is the t formula. X bar minus mu divided by standard error of x. That is what is the formula for t statistic. So now we are computing t statistic for speed, assuming that the mu value is 0. Now if you are not interested, suppose I want to test, let's say, control home. Let's go for mean value of cos. What is this cos? Cos is a data. Okay, speed. Now cos 1. Are there any missing values? Yeah, 15. You see, let us test this. This is the mean value of cos for speed. Now let us assume that the difference between the mean of speed, mean value of speed, is not significantly different from, let's say, 60. Okay. Now t-test mu is going to be, now because we brought up the value, we are comparing this mean value of speed with 60. Now we are trying to find the difference between this 15.4 and 16 is statistically significant or not. That is what is the meaning. Now you see p-value. No, the difference is not statistically significant. So the p-value is 0.4262, which means this value is far above 0.05. At 5% significance level, we can reject the null hypothesis that that this mu value, I mean the x bar value, is statistically, is different. The difference between the mu value and to that of mean is statistically significant. The difference is not statistically significant. That is the null hypothesis. Now let us test it for 20. Let's say if 20 is this 15.4 statistically, is this 15.4 significantly different from 20? Is it, we are just, if you ask the question as a researcher, that whether this, or if you want to find that whether this 15.4 is statistically different, is significantly different from this 20 or not, then you have to perform this t-test in this way. So first variable, first argument, the variable name should be the first argument, and the second argument you have the mean 20, mu 20. Now when you press, you see here the p-value is, now the p-value is very close to 0. So earlier the p-value was greater than 0.05. It is above 0.05, the threshold value. By the way, I don't have the paint program in my computer. Yeah, I don't have the paint program. So next time I should be able to. So you just have to take this p-value and compare with 0.05, which means 5%. So at 5% significance level, we can reject the null hypothesis that the difference is significant. What is this difference? The difference between the mu value of speed, the mean value of speed, and the assumed mean. That is statistically significant. Let us do one more time. So since 20 happened to be a different value, 20 happened to be statistically, the difference is difference between 15.4 and 20 happened to be statistically significant. Let us assume 70, somewhere the mid value, 15 to 16 is not statistically significant. Please be cautious. 16 in this sample, 15.4 is not significantly different from 16. But let's say 17. Yeah, 17 is all. 16 is not statistically significantly different from 15.4, but 17 happened to be significantly different from 15.4. So that is how you can keep on. Now the mean value 15.4, but for 0, what is the value for 0? Yeah, 0 is the difference is statistically significant. The difference between 15.4 and 0 is statistically significant. So we cannot compare the mean value for speed with 0. So actually what we are trying to do is, though we have some certain effect in the sample, what is that effect? 15.4. This is the average speed. The average speed in the sample happened to be 15.4, which is an effect, the sample effect. But in population, this may not be true. That is what is the null hypothesis is. Though we have some 15.4, but in population it can be 0. That is what is the judge statement. Somebody will ask you the question. If you are a researcher, if you bring up this data and show them some effect, then a person like me can ask the question, though there is some certain effect, some average effect in your, there is a valid average number in your speed. The speed, this average value for speed is valid, but I suspect this may not be the true value in the population. Then we have to perform this t-test and show them the evidence. No, it is not like that. This 15.4 is not in fact 0 in the population. It is a true value in the sample. That is what the utility of this t-test you have to perform. Is it clear now? So if it is not clear, you have to think that assumed mean. Assumed mean is any mean which you can assume. Like you can, that is what, 16, 17, 18, 20, these are all assumed means. Suppose if I ask you the question, though the average speed is 15.4 in your sample, but I assume that it should be 16. If somebody asks you this question, then you can perform the test. So what is the question? The question is against 16. Somebody asks you the question, though it is 15.4, but I assume that the actual value, I mean the true average speed, that can be 17. Now the question is this 15.4, which is the sample effect, significantly different from that 16 or not, that 17 or not, that 19 or not, that 20 or not? So in our experiment, 16 is not statistically significant. I mean, the difference between 15.4 and 16 is not statistically significant, but whereas 20, it happened to be statistically significant for 2017. So 17 and above. Yeah, even for 17, it is not statistically significant because it is less than 0.05. You see the p-value is 0.03, which is less than 0.05. So if the p-value is less than 0.05, it is significant. If the p-value is greater than 0.05, it is not significant. You see here for 17, it is less than. So 16 and 17 are not statistically significant from this 15.4. But whereas 20 is statistically significant. 0 is statistically significant. Here you see, I didn't give. If you don't give mu value, mention the mu value, it is statistically significant. This is wherever you find the p value less than 0.05, that particular assumed, the difference is statistically significant. You have to say it is the difference is statistically significant. So that is how we assume. Is it clear now? Now let us go ahead because I'll be speaking on. So whenever you want to perform the t-test, you just don't do it manually. You can make use of this function. That is what is the idea of this session. I mean my talk, not this session. I'm going ahead with other concepts. So whenever you want to perform the t-test, you don't need to worry. You don't need to compute each and everything manually because you have to know theory very strongly. You can just make use of this function instead of performing all these calculations manually. So that is, what is it? So like this, there are so many tests. There is also chi-square test. T-test is used for most of the time, t-test is used for continuous data. But most of the time, I mean, a few times you may not be having continuous data. Every time you may not be having continuous data in your hand. You may be having some categorical data. In that case, you have to go for the chi-square test. Okay. Like the other day we had data set. Let's wait. I'll show you. Suppose if you have age, salary, they're all continuous data. Gender, then you need to go for cross tabs. For cross tabs, you can't use the t-test. You have to go for the chi-square test because there are quite a few other tests. You see here the data head course. You see here, this is non-categorical ratio data. You have nominal, ordinal, interval, ratio. For nominal, ordinal, you have to go for chi-square test because they are categorical. Gender is actually, I mean, more than nominal, less than ordinal. It has categories, male and female. For such data, you can't use t-test. I mean, today people are using, but that is not no, the formula. The point is very straight. If you have numerical, non-categorical variable, then you have to go for t-test. If you have a cross tab, okay, suppose you got some, I just thoroughly make gender. Do I have gender? No. Gender. Now sample C male. Sorry, I have all problems. The computer has a problem. My health is not good. So I just simulate data set female. Then just make 10. Replace is equal to true. Now you see gender. I got this is categorical, right? It is not continuous. Non-categorical is any data variable in which you don't have this. See here, the speed is non-categorical. There are no categories here. 4447. This is numerical data. So you can convert that into categorical. That is a different thing. But here in this data set, you don't have categorical data. See here in gender, you have categorical. I'll create one more. I call education. Education. And now I already have this, right? Educated. I just make educated, non-educated. Educated, non-educated. No, only for simplicity. Yeah, yesterday actually somebody asked me a question. I will go for that. So now I have gender and I have sorry. Gender is this. Educated. This is actually education. Now I have gender. I have education. So each of them. Now let me say C bind gender and education. You see here the data is categorical. It's not non-numerical as well as categorical. So for this type of data, you can't perform t-test. That is what I'm trying to tell you. You can convert this into numerical. You know, male is 1, female is 2. You can do that, but that is not the right way of. Many people do like that. They use t-test on non-categorical data, but I don't suggest you to perform. For this, you have to go for the chi-square test. How are you going to do that? Table, gender, and education. So you got now you got a beautiful cross tab. This is a cross tab, right? And now let's use gender versus education. And, let's say gender, education, cross tab, table. Okay. I'll just create a table. Now you can go for chi-square test. You see there is a function called chi-square test, gender, education. I don't know whether I can do on one single table or not. Yeah, you see here. Now there is a warning message. It's not an error. You can just, I'll tell you why there is a warning message. You see here now, it is not a t-test. It is chi-square test. So whenever you have categorical data, you cannot perform the t-test. It is not there in your textbook. And at the same time, I think it is there in your syllabus. How to so the point is very clear. If you have, you know, the continuous, non-categorical, numerical data, then go for the t-test. If you have categorical, non-numerical data, which is not continuous in the sense there is a continuity. There is no continuity in the data. They're all incidents of, they're just called instances or incidents. For such data tables, you have to go for chi-square test. Now this warning message, now let me interpret for chi-square test, the null hypothesis is going to be, I mean H0, the null hypothesis is going to be the variables understudy or independent. So this is how independent. So this is how we make the null hypothesis. I mean, we don't make the null hypothesis. It's going to be closed. My session, I have only 10 minutes time left. At any time, the session is going to be closed. This is what is the null hypothesis. And the alternative hypothesis is going to be the variables in the study are dependent. So actually, which one is the research statement? Is it null hypothesis or alternative hypothesis? Suppose if you are doing the research, and which one is your statement? If it is categorical and continuous, you can do the t-test as well as chi-square test. No, actually t-test is not, you can't do t-test. That is, I personally don't suggest you to perform the t-test. You have to go for the chi-square. If your data is categorical, you have to go for the chi-square test. That's all. That is the condition. If your data is not categorical, then you have to go for t-test, f-test, z-test, anything, any test. If your data is continuous and categorical, you have to go for ANOVA. The right answer is ANOVA. If your data is categorical and continuous, then you have to go for ANOVA. I'm going to show you how to do that. We did not take up the discussion. If your data is continuous, numerical, go for t-test. If your data is categorical, non-numerical, go for chi-square test. If your data is categorical and continuous, go for ANOVA. ANOVA is multivariate t-test. It is actually f-test. Multivariate f-test is what is called ANOVA. Which means we are performing f-test over a cross-tab. So now this is the null hypothesis. Null hypothesis is independent. Alternative hypothesis is dependent. So alternative hypothesis is a research statement. That is your statement. So now this is going to be independent. I mean, null hypothesis is going to be independent. So with this assumption, we'll try to perform. Now let us take the decision. What is the inference from this test? We are going to take the inference from this test. What is the p-value? P-value is 0.05281. So this is greater than, the p-value is greater than 0.05, isn't it? Is it greater than or less than? The p-value is greater than 0.05. So since the p-value is greater than 0.05, we fail to reject the null hypothesis. There is no evidence in support of the alternative hypothesis. What is the null hypothesis? Both of these variables, gender and education, are independent. So gender does not depend on education, education does not depend on gender in this sample. So whatever the sample that we are studying, suppose if you are studying this data, this sample data, so in this sample, the gender and education observed to be independent from each other. They are not depending on, so which means that you cannot take decisions over gender based on education. You cannot take decisions on education based on gender. You can't say all male people have more education levels compared to the female individuals, or all male individuals in this sample data are more superior in terms of the education. You can't make I mean your statements like that. So that is what is the meaning of the chi-square. Now coming to this warning, there is another test called whenever you get across this warning, or is telling you that the chi-square test is not appropriate for this data. For that, what you need to do to get rid of this warning message, which means it is, I mean, you will get this warning message whenever your sample size is lesser. You see, we are studying only 10 data points, right? Just 10 data points. So it is this chi-square statistic, whatever we computed through this function chi-square test, is unreliable. That is what is the meaning of this warning message. Then what you need to do? There is another, whenever you encounter this situation, you need to perform a particular test called exact test. Exact test. There is one test called Fisher's exact test. It is just Fisher's. In R, you have Fisher's test. Now, what you need to do, I already have this chi-square test in my history. Now, Fisher test. Now, you see this time you don't have the warning message. This is also, this particular value is also a chi-square test. Fisher's exact test also computes the chi-square test, but with different methodology. Now, this time you don't need to think about the chi-square test. You will get straight away the p-value. Now, if you look at the p-value, it is less than 0.05. Here you see the chi-square value is greater than 0.05. But whereas the Fisher's test is, this is reliable value. Now, for this small sample, this is for the larger samples. Since our sample is not large, it is a small sample. The right test is the Fisher's test. So actually, there is a dependability in our sample. So it is possible for us to take decision that there is interdependability between the gender and education. Suppose if you prefer to, suppose your guide tell you, no, I don't go for the Fisher's test, go by the chi-square test. Say for example, your population is only 20, right? You're carrying out your study over a population 20, and your sample happen to be 10. Now it is a big sample. 10 is not a small sample. For 20, a sample of 10 is a big sample. But the gender and education, when you are obviously in social sciences, when you carry out a study with socioeconomic characteristics, you are obviously making a study on some millions of individuals. So a sample of 10 is never a big sample. It is a small sample. So if that is the case, that only depends on you and your guide. Okay, it depends on the population and the sample. So obviously, if you have some kind of, the intuition, it is so obvious that the sample of 10 is not a big sample, it is a small sample, then we have to go for Fisher's test. So in a very small sample, taking this data into consideration, there is dependability between the gender and education. So that is how you need to conclude this test. Okay, I covered you the t-test as well as chi-square test. Okay, the Fisher's test is just a backup test for the chi-square test. So whenever you think that your sample is very small, then you have to recheck your p-value by computing the Fisher's test. Okay, any questions? Unfortunately, I'm not able to explain the ANOVA and the regression. Every day it is going on like that. You please study. Tomorrow, what I do, we'll have the question and answer session. You study the regression and as well as the ANOVA. Come prepared to the session. We'll have question and answer session for just 15 minutes. And end of the session, I will try to explain you the factor analysis so that we'll finish all our sessions by tomorrow. Is it okay? Or you have any other ideas? I'm just going to unmute you all. I unmuted. First, give me the message. I will give you an opportunity to talk to me. Anybody who would like to talk to me? Okay, nobody. Okay, then if you don't have the questions, you have anyone if you ask me the questions. So study the ANOVA as well as regression and come prepared for the tomorrow's class. We'll have the question answer session and straight away I'll go for the factor analysis. And now I'll just tell you what is exactly the the ANOVA. As you have known that t-test, I'm just telling you but this is not explained in your textbook. That is why I would like to tell you this. Suppose if you have one or two equation like ANOVA always requires a crosstab. There need to be a crosstab, and in which you should have one or two or more variables. From ANOVA onwards, you are going to have the formula. It is not possible for you to compute the ANOVA using individual variables like x and y. T-test x comma y. It is not possible for you. You need to have a formula just like LHS and RHS. In LHS, you will be having a dependent variable. In RHS, you will be having independent variables. Now, ANOVA assumes importance whenever you have categorical variable at the right-hand side and non-categorical variable at the left-hand side. So that is actually the meaning of ANOVA. So in t-test, what happens? You have both of them numerical and continuous, non-categorical. In chi-square, you have categorical, either numerical, most of the time non-numerical. If you have categorical